Greetings, everybody, and hello. My name is Kevin Kotchak. I'm the founder CEO of Chemical Q Device. This is Friday, October 4th, 2024, for 150 Paclitaxel Biosynthesis AI Breakthrough. So if you're new to this, as far as paclitaxel, it's been, it's in low abundance naturally. And so people have been using it, total synthesis to start from the beginning and synthesize this in wet labs. So a biosynthesis is basically you take a living organism with like recombinant DNA, and then you're trying to produce the correct enzymes in order to synthesize this inside a living cell. And what this paper primarily focuses on is looking at 2024 literature regarding paclitaxel biosynthesis, a number of leading papers, some reviews too, but a total of 10. And then using that as a framework to carry on through a bunch of the remaining prompts. Now, this manuscript is currently up on ChemArchive. And so these are actually pulled from the manuscript. And it's basically this. So in the first part, it's too much for generative AI if I try to have it do 10 papers at the same time. There's a thing called context window, which means that if you're limited in the number of essentially words, it's expressed as tokens, then you're not going to be looking at as much of the information as you want to. So I did that 10 times for each of the papers across 3 different models for a total of 30 prompts there. And so it goes through and it does it a little bit differently than humans do, but basically the paper context is analyzed, key information is extracted, generative AI summarizes the paper, and then these 10 summaries are combined into one single summary. And when I have that, I include the paper name and the author name and the date. And then I use that as the input for more of these prompts, these generative AI prompts. Now, on the second part here, it's taking that single 10-page summary, which is about 6,600 words. It's quite robust. And then it's basically going to have a specific instruction. And that instruction is going to be like, for an emerging prompt, it's going to be like, what's your best retro biosynthetic route? What is the best type of, engineering bioorganisms? And, for some other ones, it's what's the top 10 new areas to go into based on all of this literature that's being supplied to it as a summary. And the other one are what are the top 10 challenges? Okay, so that's for prompts B1 and B3, C1 and C3. So that'll give an emerging or 2024 perspective based on the papers, the summary that I provided that. Now, this last part is basically a historical perspective, and it relies on the training data of the individual generative AI models. And this is for prompts B2, B4, and C2, C4. And without giving it all this new information to see what it thinks of it. And a lot of times the answers are coming from 2021 and before, and they go back into the 90s and these types of things as far as the big breakthroughs that has been seen in paclitaxel, either synthesis or biosynthesis. Now, what's shown on the wheel here is the total as far as all the authors go. So starting with Lee et al., 4,700, Esrich et al., 8,600, Yang et al., 12,000. And the only limitation here with the models is if the context window, say for ChatGPT 4.0, is 8K, especially if it's 8K in that specific case, some of the longer worded papers may not be fully representative. Now, as far as the generations went, as far as like ChatGPT and some of the others, in general, it picked up the context of the papers quite well. Now, when I tried to do this, represented by the author, I only just looked in this specific case at the abstracts. Now, it took me approximately an hour, so that's 3,600 seconds, and that represented about 1% of the total overall length of the 10 papers. By about 605 words. And that's actually the introduction that's included in the manuscript. Now, when generative AI did it, and I included the best, I'll show you in the next slide, the best of ChatGPT 4.0, 3.5 Sonnet, and O1 Preview, it was 6,300, accounting for approximately 10% of the original paper size. Now, the key thing here is the time that it takes is only 296 seconds across those prompts for those, the 10 best, where it's taking me 3,600. So you can see clearly that it's taking, approximately 10 times longer, and it generates 10 times more words. So effectively, that's over, in this specific case, 100 times faster on an equivalent word basis. So it cannot be underestimated. And with generative AI, it can run overnight. These are running on very robust, like the best hardware that you're going to find in machine learning, basically. These are the emerging models in OpenAI, and you're basically getting the deal of a century because it takes significant hardware to run these, and they can go over trillions in parameters in the models. So I included this structure here. And as far as, it touches on these, and it's all about the enzymes, right? Because you could do regulatory mechanisms, with DNA, RNA, there's phasey RNA, and then, microRNA, these types of things too, that one of the papers touched on. But basically all throughout, you hear about the C13. So this is amino acid-like for the tail. And then some of these other here too, it's challenging to find the right enzyme to efficiently produce this oxytane ring at D. And just in general, and keep in mind, this is going on within a cell, right? These papers are addressing. And this tetracyclic core 2, you'll see enzymes for that. And then also these hydroxylations and some of the, surrounding ones, or if they're acetylated or benzylated too. Now, this is the first part here too. So what I included on the left is basically ChatGPT 4.0's response to one of these. So this paper is a bunch of Stanford researchers, reconstitution of early paclitaxel biosynthetic network by Chungting Lui et al. In this year. So it goes through, and the instruction that the prompt has, and again, the prompts are in detail. There's a total of, like 163 different generations across 15 prompts. So this prompt is something like, provide all the detail of how this paper advanced the paclitaxel biosynthesis field. So it goes reconstitution of a 6th step, and I check these. So I read these. So tuning promoter strength for T5 alpha H, this specific enzyme, structural characterization of new oxidized hexadiene products. And for the most part, they check out. Like all of this information is pulling directly from this prompt, the single prompt giving to ChatGPT 4.0 out of the paper as far as what's causing the advancement in paclitaxel biosynthesis. It's really an amazing thing how far this technology has come, even going back to the ChatGPT 3.5 turbo era, that you couldn't do anything close to this. And it's highly reliable. And like I said, I'm mostly finding minor issues if it attributes a different author, and I'll show you that in a different slide here. So I read through all of this, and I double check the information with the paper. Like I said, in this specific case, this, as with many of the other ones by ChatGPT 4.0, it's a really good summary. Now, there's things, if you try to do this on your own, if you make the prompt too long, and say for in this case, I really wanted the essence of the advancement in paclitaxel biosynthesis, and I also wanted the emphasis on the well, in this specific case, it's mostly on the specific paper, and I'll get to some other detail with the other prompts. So when I did this, I ran 3 different models across the 10 different papers. Now, the issue with the 3.5 Sonnet is it's just not nearly as detailed, right? These prompts see 349 words, or these generations, 264 words, 311, 314, whereas compared to ChatGPT 494, 446, 648, 441. And ChatGPT 4.0 has been, the #1 model. Now with the O1 preview, you can get really awesome results, super detailed, 1,000+ words in the generation. But according to the judge here that I use this other AI model called Scholar GPT, which is also an OpenAI variant, it didn't seem to favor the verbosity of the O1 preview. And I'll show you an O1 preview generation that actually I thought was pretty good. So O1 preview by OpenAI, it basically represents the cutting edge chain of thought, advanced reasoning, like similar to how expert scientists think in the field. And with paper 10, the O1 preview, it has a lot of Chinese in it. and it didn't actually process that specific one. But the ChatGPT 4.0, the abstract was written in English, and it also seemed to pull the information from the rest of the paper too, at least on the scientific terms. And I'm not fluent in Chinese, so I can't go much further than that. So the average we see, based on these, the ChatGPT 4.0, the highest score. And again, reading through, a lot of these and seeing it as they come out. And a huge key is the formatting that, just how does this look like? How detailed and scientific does it look like? In this specific case, it's more going to be about complicated names for enzymes as opposed to percents and these types of things. But basically, this is a close approximation of how it looks. I had to do the paper or the manuscript in LaTeX, which is different than, it's going to look a little different from the ChatGPT. So pretty impressed with that. Now, to give an idea of all this is if you look at all these individual prompts, except for 10 with the 01 preview with the paper in Chinese, is that, you see in each of these is that they're way faster than any theoretical human can do. Now, when I calculated this answer for the theoretical human, I calculated it off of 3 ChatGPT 4.0 prompts, and I took the fastest one to give the benefit to the human. And I used that as the standard reference throughout the whole paper. So as you can see here, the same thing, it's like 1,380 seconds for the human. And there are 3 different prompts based off of the original getting information from the papers, this B1 and this B2, which are prompt Bs, which are basically going to ask about retrobiosynthesis, either an emerging or a historical perspective. So you see here, so I chose this specific one, this 1,380 seconds, and all along I tried to give the optimal human answer the benefit of the doubt, meaning that in words, you see a lot of these, say if, the averages down here as far as words, 819, 448, 715, and even the sonnet was 375. I said for the human to create 250 words, okay? So I try to create all the benefit of the doubt towards what it would take an expert human researcher to do these tasks. And they can do a lot of these tasks, but not consistently and not all throughout the day. And say if I switch some of the input data, the 10 summaries, to a whole different new 10 summaries, the human researcher is likely going to have to treat that as like a whole new set of studies. Whereas with generative AI, it's the computational processing is at such a high level because the hardware is really good, the software is really good, and we're talking about communicating with AI in English, the rest of our lives, basically, and to wean away from this like heavy, complex coding environments. So when I showed this graph here, the fastest theoretical answer, 1,380, and I actually took the cumulative in this case for 2 different prompts, and you can see it just goes up just very slightly. So just meaning that, the human answer is slower than 8 generative AI prompts in this specific case. Now, for the B1 results, you see like the top 3 models were 01 preview, Llama 3.1, 405 billion. This is a Meta Llama model, 9.3, and the ChatGPT 4.0. Okay. The main issue that I've had with the Llama, this 405B, which is their flagship model, it's an open source model, which is you could do a ton more with it than OpenAI or Sonnet or Claude, is that it just tended not to also include references. So in this specific case on the right, this is an 01 preview generation of prompt B2, which is asking for a historical perspective of Paclitaxel retrobiosynthesis. And what's shown here basically all throughout is this Dennis et al. We see in 1988, Holton in 1995, and then this Croteau in 1993. And most of these checked out if it was just like a year off, I think in 1 or 2. But for the most part, I could find this literature that the 01 preview has as it in its parameters, and it's given also with the references too. So for what it is, as a research tool, you cannot turn down this software at all, because at the bare minimum, if you just want to know, like, instead of spending hours and hours and hours, more effectively use it to generate these summaries, In this specific case, so it's going to start with, so it's retro. So it's going to remove the C13 chain and then simplify the text in core, retroclazen rearrangement. Okay. And in that specific case, for historical perspective. So, the thing with O1 preview, yeah, it's verbose. But these models keep getting better. They're not like we're not even close to like as far as maxing out. And the performance of this matched by the speed is very good. So the only thing that I can find is in this next set of prompts. So this is going to be asking for top 10s. So for the 3.5 sonnet, it's asking for a top 10 regarding new research areas. And then the next set of prompts, the C3 and C4, top 10 challenges. Now, some of these I did not have room in the actual manuscript. The generations are in 7 different supplementary files, again, accounting for 163 generations, and you could look at those. Now, I'll give you an example. So this 3.5 sonnet tends to be a little bit brief. And so this is the C1 3.5 sonnet, which is the second one here. So it shows that there's, 414 words. And this only took 14.81 seconds, which is pretty good. So all of these goes through these are the original papers and the summaries that I had to condense down into. Lee et al. With the top one. And actually, this first one was the only one that I could find based on this researcher that this actually was from a different paper. Okay. Now, 2 through 10 were a lot better, and every one that I checked out. So we're talking about this taxidiene 5-alpha hydroxylase, and it says by Bluell in 2024. Esrich with this microbial consortia that checked out. Sun et al. 2024. Again, these are like bleeding edge papers, and very few, if any, of the researchers in this area are going to be an expert across all these. Now, some of the papers were more reviews, say at least 2 or 3 of them, and other ones were more, original research. But still, there's a lot of information to extract. Say if it's putting that information into reviews within the past couple years, as opposed to like a historical perspective, which would likely include, 2021 and before, like the more cemented, historical data. So Xiaonan et al. In 2024 with this cytochrome P450 enzymes. And just time and time again, for the most part, all of this is like coming directly out of the papers that I provided. Now, for additional framework is that I did 3 additional manuscripts before this one. And the key technology is called document retrieval. And then the first ChemArchive manuscript that I put up, it really showed me that it has the capacity of just finding things deep inside either supplementary files or the main papers. And I'm talking like organic syntheses, JAX papers, Nature Communications, like very significant, publications. And then, I've also proven it with some image stuff with high dimensional and complex images as well. So this has all been built up over time to, basically be able to have the confidence to do this on a huge study like this, really focusing in on 10 papers. And then, so the rest of this generation by 3.5 sonnet, again, checked out. So some of the earlier things with this GGPP, which is kind of like an earlier precursor that it talks about too. And I invite anybody too to not only go through, there's 4 generations inside the manuscript, and then there's 159 more inside the supplementary files. And if you want to search by model name, like the Llama 3.1 405B, and again, I had some issues with that specific one with references, but especially the OpenAI models, or the, ChatGPT 4.0, and then the O1 preview, just very consistent, especially ChatGPT 4.0, as far as, detailed, very accurate. And again, they've been going through iterations since we had access to like GPT-2, many years ago. So again, this software is still, it's still getting more and more awesome every, month. And actually, what enabled this study in specific was the ChatGPT 4.0 release in May of 2024, and then the 3.5 sonnet the month after in June. This is how fast this industry works. And I've had other studies where 3.5 sonnet even on my most current data, would be still number one over ChatGPT. And July was Llama 3.1, 405 billion parameter model. Skip August, go into September, and then now we're talking like the ChatGPT 01 preview. One of the only issues that I had was the 01 preview did have rate limits. So I suggest only using it for your mission critical prompts, not just getting used to it like you would like with ChatGPT 4.0. Okay. So the rest of this prompt or this rest of this generation, checked out. And again, I wasn't cherry picking or anything as far as like this one or that one, except for it's like Llama 3.1 405B. That's in the supplementary files, but it does have issues with, citing different names. So some of these models are thought to be over 1 trillion parameters, like ChatGPT's models, and you don't want to ask it too many things. So for instance, for ChatGPT, I say, provide me a recent biosynthesis and cite your sources with it. I wouldn't do too much further than that. Okay. It's a little bit better than others, but if you start asking 2 or 3 additional things on top of that, you're likely going to take away the quality of what you really want to know. And this was proven in I did 4 reports in July, and then the previous 3 manuscripts to this one too. So what's shown in the table here, so these are 9 different models. So across the study, I used 10 different LLMs or LMMs, okay? Large language models or large multimodal models. And there's 4 different prompts. So C1 is going to ask about top 10 new research areas shown by the 3.5 sonnet in an emerging way, meaning that it's based on this 10 paper summary. C2 is a historical, which is a direct prompt, still asking for references. And then C3 is going to be the top 10 challenges. And I actually read through that in the supplementary before this discussion, and it did a good job there too. So yeah, that's the core thing is you want to ask it the core, what you're trying to figure out, like what advancement you want to make in the field. And then the second thing is always ask to, cite the references. And you can actually in many of these models, or at least some of them, ask in specifics, provide the block of text where you got that answer from. But this is a bigger project. And then, so I didn't necessarily do that, but that's a reasonable request. Whereas, page numbers, those are a little bit trickier because they don't look at the page numbers sometimes the same way you do, or line numbers. So yeah, that's another thing you could do too, is a block of text. Ask it for where it got that information from. So in this specific study, as shown here with 3.5 sonnet, ChatGPT 3.5 sonnet, very similar. Some of the times with 3.5 sonnet are going to be lower. It's about half as long as the ChatGPT 4.0. So, just keep that in mind and keep detail in mind with 3.5 sonnet. Now, the one that was surprising was this wizard 8 by 22 billion parameter, which is the fine-tuned version of the Mixtral 8 by 22 billion parameter. And basically this is a more limited model. Like its active parameters, I think just uses 2 mixture of experts out of this 22 billion, something like 40 to 60 billion. So, that was the shocking one. Now, what I'll show you here, so if I took 36 of all these C1 prompts, or C1 through C4, that's only 752 seconds. And I call this advancement number 2 because the quality on a lot of these was very good. And then the time is still significantly faster than an optimal human. So in half of these cases that's shown here, the C1s and the C3s are based on the 10 paper summary, but the C2s and the C4s are a direct prompt. But still, for an expert human to answer a lot of this, unless you're very directly working in the field, you would probably have to do a little bit more research. Okay. So anyways, the single optimal human answer was determined before as the fastest. Everything I did, I tried to keep the benefit of the doubt towards the optimal human with this. And the big breakthrough that was seen here was the generation tied with this speed that we consistently see. And we could see with these C prompts as well, these 4 different C prompts, is that, with the generation quality and it's it was so much, it was such a huge jump to go to ChatGPT 4.0 and 3.5 Sonnet than if you were using 3.5 Turbo. ChatGPT 4 wasn't, it had basically, it was slow as a chat, and it wasn't as good as ChatGPT 4.0, but it showed promise. Let's just say that. Okay, so this has been episode. So this is 150 for paclitaxel biosynthesis. Takeaway here is that the quality has matched the speed, in my opinion, and seeing this across all of these different answers here, like this level of detail from this generation from O1 preview. And you can see this in the manuscript too. I included all the major generations, and even going back to the original, extracting information from original papers using document retrieval, and then I chained those responses together to use, So so this has been discussion 150 for paclitaxel biosynthesis. The paper is up on ChemArchive. Expect a lot more on the side of, high dimensional, complex data, combinatorial problems with synthesis, so either synthetic or biosynthetic drug compounds. Okay. This has been Friday, October 4th, 2024. And for Paclitaxel Biosynthesis AI Breakthrough, my name is Kevin Kocek. I'm the founder CEO of Chemical Q Device. Have a good rest of the night and have a productive rest of the week. Take care, everybody. Bye.